16 అమ్మా. ఎంతమంది జాయిన్ అయ్యారు ఇప్పుడు? Only 66 members joined. Hello? And rule number 6. Number 2.
Ma'am.
ఇప్పుడు క్లియర్ గానే ఉంది కదా నా వాయిస్? హలో మస్ట్ సే
క్లియర్ గానే ఉంది. క్లియర్ మ్యామ్.
ఓకే. మిగిలిన క్లాస్మేట్స్ కూడా జాయిన్ అవ్వమని చెప్పండి. అతను నేను ఒక్కదాన్ని మెసేజ్ పెట్టుకుంటున్నా, జాయిన్ అవ్వమనండి. ఒక 5 minutes, within 5 minutes. సెషన్ అయిన తర్వాత ఫీడ్బ్యాక్ ఎవరు చెప్తారమ్మా? ఫీడ్బ్యాక్ చెప్పడానికి ఒక 4 members రెడీగా ఉండండి. 59 కీర్తి, మనోజ్ఞ మీరు చెప్తారా? 2 minutes. టాప్ చెప్పాడు. మీకు ఏది వచ్చినా చిన్నదైనా పెద్దదైనా చిన్నదైనా కూడా ఏమి రిజిస్ట్రేట్ చేయదు. రిజిస్ట్రేట్ చేయకపోతే అడగదు. అప్పుడే మనం పెట్టిన ప్రోగ్రామ్ కానీ యూస్ అవుతుంది. అవునా? ఓకే. మీరు ఎంత యూటిలైజ్ చేసుకుంటే అంతసేపు ప్రోగ్రామ్ 1 to 1.5 hours సెషన్. Roll number 13. 14.
Present, ma'am.
15.
Present, ma'am.
17. 20.
17 present, ma'am.
Okay, no, thank you. Thank you all for connecting this session. పిల్లలు వాళ్ళు కూడా జాయిన్ అవ్వమన్నట్టు. హలో హలో అంది.
Yeah, hi ma'am, good morning.
Hi, good morning. Okay, I will start the program now.
Sure.
Good morning, one and all. Today, I welcome you all to this Industry Institute Interaction Program on e-commerce. This program is organized with the objective of enhancing knowledge regarding the latest technologies and methodologies used in industry. Today, Mr. Untitled Sri Patina is here with us to enlighten us about e-commerce and revenue generation using recommendation systems. Now, I request Vimal Kirti to introduce our chief guest, Mr. Untitled Sri Patina.
Good morning, everyone. Mr. Anudip Sripatina has 6 years of professional experience in driving any size and format of data towards insights and predictions using Azure Cloud Services. He worked as technical lead in Capgemini for 2 years. During that period, he extended insights using data engineering and ML for supply chain data of the client to solve the business problems. He worked in the role of big data developer and gained insight solutions. He set up Hadoop cluster using Docker and applied ML algorithms on big data by remotely running PySpark code on Hadoop cluster. He worked in Cognizant as programmer analyst for 4 years. He trained the faculty of VIT on implementation of big data and AI using Databricks in Azure. In 2 years of mentoring fellow IT professionals in AI real-time case studies as part of PGP program of UT Austin. He delivered 18 guest lectures on AI and ML, cloud computing at various international platforms and universities. It is my pleasure to welcome such a distinguished person, Mr. Anudip Sripatina, to deliver his lecture.
Thank you so much. Good morning, everyone. So I hope I am visible and my audio is clear to everyone.
Yes, visible Anudip.
Thank you, ma'am. So let us start. And before starting, I just want to make sure that everyone is comfortable before I get into the session. So before going into the session, I just wanted to talk to you guys. I know there was an introduction given to me, but I'll tell you what's not there on the screen. So I am Anudeep, and I was born and brought up in Vijayawada, and from past 2 years I had been delivering lectures in VIT University and other international platforms, but never got a chance to give a guest lecture on my hometown. So after moving to US, now I got a chance to interact with people in my hometown. So it feels really good to talk to you this morning. I don't want to bore you all on a Monday morning, so I would want you all to feel free to talk in between the session. I would want it to be in an interactive manner. I just want to um, make sure that I answer all of your doubts or questions that you might have in your mind. Something that you could take away from my session, because I wouldn't want it to be a boring PowerPoint presentation or something. So that is my agenda. So before going into my PPT, I would always want my participants to talk to me and ask what they are trying to get from my session. So when you first heard about that there's a session going on e-commerce and recommendation systems, what is that first you had in mind that might have excited you to join the session, or you might be eager to learn something? So what is that? I just wanted to know so that I make sure that I cover those points. uh, it will be great if you could respond even on chat. I wouldn't mind chat or voice. So I just want to hear out from you guys. While you guys think about it, let me tell you guys what I'm going to cover in the agenda. I'm going to first talk about data, on how data is being generated in this world, current world, and why it is so important for us to value the data that is being generated, and how do we convert it into a meaningful information. And then I'm going to talk about science of handling the data and give you a gist of industry related stuff that would help you to understand how data is being treated in the industry. And finally, I want to talk about our main topic, which is how recommendation systems are being used extensively in the e-commerce, or for that matter, any industry. So my main focus during this point would be e-commerce, and finally, I would want to talk generally about artificial intelligence in our daily life. So yes, before going into the session, would anyone want to highlight what you want to take away from the session? Um, Feel free, guys. Hope I am audible and chat is accessible to all of you. And yeah, I can't proceed to the next point unless you tell me what is interesting to you, or what is that you want to take away from the session. So
How we can use the data.
okay, yeah. Anyways, I would cover that in my session. So I hope if everyone is looking for that, it is better that I would go ahead and cover in the session. So why is that we call data the raw gold, or why is that we call the data the new oil? So it is because the enormous amount of data that is being generated. So let us understand, how do we measure the data? I hope all of us know terabytes. It's nothing but 1024 GB, and 1024 terabytes is called something called petabyte, and 1024 exabyte is called, sorry, 1024 petabytes is called an exabyte, and 1 trillion gigabytes is called zettabyte. I hope we all know, we all must be using our 2 TB hard disks and 3 TB hard disks is now what we are using. Just imagine what it is when we use 1 billion terabytes. That is called as zettabyte. Now this 1204 zettabytes is called an yottabyte. You might be wondering why I am talking about this quantity of data. It is because I want to show you how much it is being generated on a daily basis around the world. So these are the statistics that are collected from a source which is trying to give us the data that is related to 2022 and also a projection, if you can see in the third graph. You see the kind of data that is being generated, copied or stored is around 180 zettabytes. So this is why I was trying to show you what is a zettabyte. A zettabyte is nothing but a 1 trillion gigabyte. And then you can see the kind of projection that is being projected onto 2025. It is 180, it might exceed 180 zettabytes, which is very, very huge. And I want to draw your attention back to the graph 1 wherein we have number of data centers. So basically what are these data centers? These data centers are nothing but the place where you store the data. In US, you have 2,670 data centers, and most of us are not known to what is the significance of having a data center. I hope you heard about data localization. So this terminology is about localizing the data storage. There's a huge discussion that is running between the Indian government and other officials regarding this data localization. So Indian government has demanded the US companies to make sure that they have their data centers. As you can see, we only have 123 data centers. If you just compare with the US, companies like Google, Microsoft, all these companies are storing our data, yours and my data in US. It's not storing in India, which is like critical. It's a security issue, right? So for this reason, we have to make sure that the data centers are there in India too. So this is why I had put this for your reference. So this is where you will have to understand why data centers are necessary for us. I hope to show you what is a Google data center looks like. Let me just show you in a minute.
A data center is the brains of the internet, the engine of the internet.
It is a giant building with a lot of power, a lot of cooling, and a lot of computers.
It's Google. I'm Joe Gava, Vice President of Data Center, and operate Google's data centers. We're also sets for our data centers. This data center here in South Carolina is employees that know.
So this is how a data center looks like, and this is how it looks like from inside a data center by Google.
Provide them a fun.
Man hours is amazing.
Google, we have the experience pretty. Is our closer.
So this is how it looks like, guys.
Various layers of higher level security to be on a pre-author to get into the center. For instance, or being authorized at a true. I noted that most big car distribution coming from the outside yard, we bring in the high voltage power, distribute across the bus bars to all of the customized bus taps that are basically plugs where we plug in all the extension cords. All of our racks don't really look like a traditional server rack. These are custom designed and built and high performance. Maybe they're just no longer efficient. Managing those drives from the time that they're checked out for the server till they're brought to any drive that can't be verified as 100% clean. We crush it first, and then we take it to an industrial wood chipper where it's shredded into these little pieces like this. In the time that I've been at Google for almost 6.5 years now, we have changed our cooling technologies at least 5 times. Most data centers have air conditioning units along the perimeter walls that force cold air under the floor that then raises up in front of the servers and cools the servers. In our solution, we take the server racks and we butt it right up against our air conditioning unit. We just use cool water flowing through those copper coils that you see there. So the hot air from the servers is contained in that hot aisle. It raises up, passes across those coils, where the heat from the air transfers to the water in those coils, and then that warm water is then brought outside the data center to our cooling plant, where it is cooled down through our cooling towers and returned back to the data center, and that process just repeats over and over again.
So, as you can see, that is how a data center looks like, and that is how it maintains. It needs a lots of cooling efforts because it constantly generates a lot of heat to maintain these servers. And this is where the cloud technology comes into place. I hope you guys must have heard about Azure cloud technology, AWS cloud, Google cloud. So all these cloud, how does they work? The data that we are storing doesn't store in our local, which is our hard disk or our PCs or laptops. It gets stored in a data center that is away from us. It is somewhere else, but the data is stored. That's how your Google Docs work, and that's how your um, most of the businesses nowadays are working by using with the help of these data centers. Let me draw your attention to leaders in data-driven decision making, which is currently that is happening. Now, any business that you take, what it is trying to do is to do something called digitalization. Now, what exactly is digitalization? It's not just improving the website that they have, it's about how they are dealing with the data. Previously, in our legacy systems, as in, I don't know, if in your childhood you must have heard about 250 MB memory card, and as you grew up, you must have heard about a 4 GB pen drive. Now you can see a 32 GB pen drive, and now we are also seeing a 2 TB hard disk. But back when it was just 10 years ago, a decade ago, it was very tough to get a 1 TB hard disk, and you barely get 512 GB of memory in your highest costly laptop. This is because the computational power and also the storage power for the data had increased over the time. And now companies want to change the strategy on how they are dealing with the data. So these are the industries where the data driven decision making is happening. As you can see, most of it is being applied in the banking. Right now, the banking system is pretty good in India. And insurances, I hope all of us know about life insurance corporation and such kind of companies that are using data driven decision making. There are so many private insurance companies that are using this. Telecom, I hope no explanation is needed. The way Geo is using its user base, or the way Airtel is using its user base, it's all by using the data driven decision making, which is nothing but your artificial intelligence. So retail is the place where we're going to talk about our e-commerce. E-commerce is also applying a lot of artificial intelligence. That is what we are going to see in this lecture, on how they are utilizing this data and driving this towards insights, and thereby utilizing the insights so as to grow the business. I just want to make it a point in terms of finance too. It's not just in a data aspect, even in a financial aspect, the way the analytics industry is going. So analytics, artificial intelligence, data science, data driven decision making, all these are terminologies that are being used so as to apply the same concept, which is nothing but taking the data from the source, using it and pre-processing it the way we want it, and then finally getting the insights. In an informal methodology, we call it torturing the data in such a way that it confesses some information to us. So this business is has so much power, and it is growing enormously all of these years to come. As you can see, in 2026, your analytics as a service is going to grow to a $101 billion business. So what does this analytics as a service mean? Analytics is nothing but driving the data towards insights. So this analytics business as a service. So there are certain companies right now which are just doing the analytics by using the data of the customers. They're doing nothing else. So these companies create certain softwares to uh, you know torture the data to get the confessions of what it has to say. So this is called analytics as a service business. And so as I showed you, maintaining this data centers is also a business that is of 10.7 billion dollar business. And business intelligence is what I'm going to show you next. What exactly is this business intelligence? That has a market to go up to $17.6 billion. And yeah, the data center business is again $58.3 billion business. So this much is what the potential of artificial intelligence has for all of us to offer. So there's a huge potential for all of us to learn this kind of science and try to get into this kind of roles where we try to utilize the data that is being generated and give insights to the companies. Let me proceed further, guys. So as I said, what exactly is this business intelligence all about? So business intelligence is all about taking the data from a source. So what can be your source? It can be a sensor, it can be a survey, it can be something like a data that is being generated from text. So for example, we all are using Instagram. So let's say we are going ahead and doing some comments in a public page. Let's say for example a Nikon camera page is there on Instagram. So we all jump into that page and say, hey, I like this camera, I want to buy this. Let's say we did that. So what would happen is that the people in the Nikon company try to take up all this data that is being generated from the social media of Nikon, and they try to collect this data and try to analyze the information and transform it the way they wanted. So here is where they try to collect the comments that we made, and they try to analyze these comments by using NLP. NLP is natural language processing, that is a part of artificial intelligence, and they try to transform the data in the way they can understand. As in, if anyone say I want to buy, that is shown as a positive note to the company, isn't it? So the company wants to reach out to you and tell, hey, we understood that you want to buy our product, are you interested? That's how they reach out to you. Let's say you say, yes, I want to buy, but I'm looking for some discount. So it wouldn't cost much for a company to provide a 10% discount to a potential customer, right? So that's how, using that valuable information, a decision process would be made. The decision process is nothing but giving you a 10% discount. And by giving the 10% discount, what is happening? They had drove you from wanting to buying the product, which means it's a business. That's how your revenue is generated. But you understand one thing what happened here? It is that after you commented, maybe after few days, is they reached out to you. What if you say I want to buy the camera, and immediately you get a call back from the company? How does that sound to you? That is called artificial intelligence and real-time streaming. That is a separate advanced science to business intelligence. So I hope I'm clear about what is a business intelligence. Is anyone having any questions right now regarding business intelligence?
Clear, sir.
Great, thank you. Now, where are these business intelligence is being used? What is this BI? This is called abbreviated as BI, and it is being used in banks so to assess the financial risks. If you just talk to anyone who is working right now, they would say that they would be using credit cards. And let's say I am using a HDFC Bank credit card, and I was living in Vijayawada, and suddenly after some 10-15 minutes, there's a transaction that happened from my card in Hyderabad. Is it possible for a card to travel from Vijayawada, that was the location of the card, where the last transaction happened, and immediately in 10 minutes later there's a transaction that happens in Hyderabad from the same card? Is it possible to travel Hyderabad in 10 minutes? No. So this is called as a fraud transaction. So these fraud transaction need to be tracked. So these are the financial risks they try to address. Also, it's also about loan. Most of the business intelligence is being used in the loan business, where if I want to apply a loan, I go to a bank and try to apply for the loan. So what they do is they take out my historical data based on the information that we provide, based on the assets that we have, the valuation, the kind of job that we do. Based on that, they give us the loan. So this is how business intelligence is being used in the banks. In the hospitals, analyze patient outcome and readmission rates. Um, I don't know whether you had been exposed to this kind of a hospital, but most of the time in hospitals like Apollo or somewhere in the US, mostly in the US, they try to do this procedure. All of your medical records are being tracked, and they'll be utilized to understand how much chances are there for you to get sick, and they try to contact you at that point. So let me tell you the scenario in the US. For example, here, let's say there are people who are 60 plus and they live by themselves, and those people would not have any help for them to stay, which means they would have to handle everything by themselves. In such a scenario, when you have an hospital that uses business intelligence plus artificial intelligence, they would be trying to predict, you should be readmitting into the hospital soon so as to treat your illness, some kind of insight that they would get from the patients that they are treating. So all of this can be done using the historical data they have, right? We're going to discuss more about how these things are being done, but I just want to set the context on what exactly business intelligence is. So airlines to track the ticket sales and flight occupancy. Um, that's a, I don't know how many of you tried to play around with the predictability of booking a seat on IRCTC. So there's so many, even the IRCTC website offers you the probability of you getting a seat when you're trying to book. So business intelligence is being used there. How do they do is that they try to utilize the past data that they have and try to show you that based on their information that they have, this is how much probability that you would get a seat during this season of the travel. So this is the ultimate goal of a business intelligence. The whole point about business intelligence is that it tries to analyze the historical data that they already have, and they try to understand what it is trying to convey, the information it is trying to convey, and based on that the decisions are taken. This is what business intelligence does, and mostly it doesn't try to convey us anything that would happen in the future. In business intelligence, we only try to understand what was happened. But in the current scenario, this is not enough. So the business intelligence has become a casual thing now. Every business has this business intelligence technology with them, and that's how they're thriving right now. But what is the future of this business intelligence is nothing but your artificial intelligence. For you to for you to get a valuable insight from artificial intelligence, you would have to have a lot of data that could help you in predicting the future. Let's say in your first semester you got a very good grade and you got a very good CGPA. Can we predict that you would do well in the second semester? We can, but we don't know how much accurate it would be, isn't it? So if I have the data that you had scored well in your first semester and also in the second semester you had scored well, there's a high chance for me to say that probably you can do well in your third semester, and you prove that as correct. I can tell very much probably that your fourth semester is going to be very good. So this kind of estimation can be done only when there is enough of data. So when I'm talking about estimation, this is called artificial intelligence or data science. For you to up the game in artificial intelligence, you should definitely have a lot of data. So how do you collect this data? How do I get the data from a business? Let's say for my e-commerce business, how do I get the data? So there are two kinds of sources that you can get data from. One is your primary source of data and the other one is your secondary source of data. So how do you say that primary source of data can be reliable? Is that this you can be getting by doing survey within the company, within the e-commerce company, let's say, since that's our topic. And external data is to understand from the users. I hope when you're using Instagram or when you're using Facebook, it keeps asking you user survey. It would show you a dialog box saying we are asking only a few people. I hope you would be interested to give the survey, kind of stuff. So why are they doing this is to understand your feelings about the product. Likewise, by interviewing your usage, they're gonna get some info from you and they're gonna improvise their product by using that information. That's how your primary external data works. So through surveying within and outside, both from the clients and the employees, you're gonna get some primary data here. But is that enough? No. The data that you get here can only be used in your business intelligence and try to say that, this is what is the current info. But what if you have secondary data, as in, let's say in your e-commerce website, one particular product is getting so many clicks and it is getting purchased so much uh, within a short span of time. So these are the kind of insights that you want, so as to make sure that your e-commerce business is doing well, right? So for that, you're gonna use certain Google Analytics products that can be available, that are available, and you're gonna do some, let's say, where do you find your product reviews? Generally in reddit.com, something like that. So we try to get such a data from other secondary data sources. Let me give an example. So if suppose you have a bad experience in taking a flight from Vijayawada to Hyderabad in an Indigo Airways, for example, I don't know, like, people these days just go to Twitter and tag them and ask for help, or they just rant about it, and the company comes back with a reply in that particular Twitter microblogging website, right? So there they become active not just for the customer assistance but also to take the data, the feedback and such stuff, so as to make sure that they have enough data for them to improvise their product, right? So this is how we collect the data. And apart from collecting the data like this, there are so many ways of collecting the data. I think you must have heard about the terminology called Internet of Things. This Internet of Things is nothing but, nowadays sensors are being attached to almost everything. Your not just industries, even there's a concept of smart homes. I hope most of you must be using Alexa at home to switch on your light. So such kind of devices are collecting a lot of information and data from the usage, and they are trying to make insights from that. So likewise, sensor data and also internet, by using the Internet of Things data, by the data that I was telling you, the way we use the smartphone today generates a lot of data to the companies. Also, one fun fact, when you have an Instagram app on your phone and when you talk on voice call, general voice call, you say, I want to buy something, and Instagram catches that and it shows you an ad regarding that. For example, hey, to your friend, you might say, hey, I want to buy this camera, it looks so good. So you open Instagram, after a while you see an ad from Amazon.com, buy this camera, or if not Amazon.com, you would see from Nikon.com asking you to buy a camera. So this kind of technology that they have been using is nothing but, they have taken the data in the form of voice that you just told that, I want camera. It was immediately analyzed and it was given you as an ad. Let's say you badly wanted to buy a camera, you would go buy that using that ad. Let's say it gave you some discount, so you would buy that, isn't it? So this is how data is being generated, and this is how that is being processed immediately, and that is being given to you as an ad, and revenue is being generated. So data collection has become a very important aspect in this whole problem that we are trying to understand. So apart from these, based on the Google, I don't know, if you use Google Chrome, the website history will fetch you a lot of data for you to analyze. As you can see, I just tried to summarize the ways you can get data for different purposes. There are so many ways that you can get the data. Geolocation devices will give you the location of the person. Whether you had observed when you are googling something, it asks you the location so as to provide local dealers for you. As I said, natural language processing, the kind of text that you send out in an public platforms, your e-commerce sales data, your purchase orders, your loyalty cards that you use, the kinds of calls that you make to customer service, all these are data points that you are giving out from yourself, and that can be used so as to create insight for you. What would you need? As I said, let's take the scenario of a city. There's a lot of smart logistics, smart parking. Smart parking, as in people who have cars, once upon a time used to put their head out of the window, look at the back, look at the sides, and had to park their car. But nowadays, I hope you watched the video of a Benz which parks by itself. I hope you heard about Tesla. That's the best example, wherein the Tesla cars drive by themselves. Forget about parking. So, smart water management, this is the electrical and electronics department would be doing projects so as to sensor the level of water in the tanks, and they try to switch off the tank. So, smart water management, smart healthcare, which we just talked about in the business intelligence part, and you have smartwatches that tries to tell you the heart rate. So, how IoT is being used to create the data? um, People who have Apple Watch would have experienced this. They get insights if you pay about your sleep, about your heart rate, about your health, all of that. So these are the ways that data is being generated and utilized immediately. Let's dive deeper into what is the market. When you're doing a business, you would try to understand what is your market size. Let's say you're trying to do an e-commerce business. Let's focus on the recent times when we had a pandemic. In the pandemic, it was very hard to go out and buy stuff, and that is where we tried to take help of the e-commerce, and the e-commerce companies like Amazon, Flipkart have come up to help us with delivering the needs that we wanted. How did they do? How do they come up with these policies that helped us during the pandemic? And how did they do all this is by doing something called market analysis. By understanding the needs, they have made sure that they worked in shifts so as to cater the needs of us and try to prioritize products. And they had segmented markets. For example, they call it tier 1 city, tier 2 city, tier 3 city, wherein the tier 1 cities are those which has metro connectivity, as in there will be international flights, there will be domestic flights that will be flowing very, very often. For example, Chennai, Bangalore, Delhi, Hyderabad, etc. So that's how they categorize the markets, and they try to analyze how much need would be there in that particular area. Why market is analysis is very important in business, especially in e-commerce, is to our business would go bad if we don't focus on the market where there's a high demand. When there's no high demand, there's no point for you to invest all your money on technology and drawing insights, isn't it? So this is the reason why you need to understand the way you are trying to target the market. Again, for you to do this market analysis, you would need business intelligence. There should be some amount of data that should already tell us what is the demand. For example, let's say all of us want to build a new e-commerce website, like something like Amazon. What would you and I do? We try to get the data from these companies that is publicly available, understand how they have in which cities, how did they perform by selling what products. You must have seen this kind of stuff in the movies too, in Telugu movies too, when they were trying to sell drinks, hot drinks and cold drinks only through e-commerce. So how did they come up with the idea? They had done the market analysis. They had segmented their market specifically to drinks, and they tried to come up with a new name for that, and they were delivering it, and slowly they started making profit. So this was a very naive way of dealing with the problem. But how does engineers do is to sit and analyze where they have the market, how do they do the delivery and all of that stuff. So here is where business intelligence will come into play. Let me tell you an example on Netflix that will help you to understand. Tell me, how many of you would watch Netflix continuously if there was no recommendations made? As in, it was just plain videos that are there, and you will have to go and search for the videos. It wouldn't give you automatically. How many of you would sit and watch the Netflix continuously? Any one of you does? Don't tell me out of the 100 participants, none of you are watching Netflix. Yes. Okay, you're raising hands. I understood. Yeah, okay. So you're watching Netflix. So Netflix had this problem of increasing its revenue by recommending the videos that you would watch. So they had to build something called a recommendation engine so as to keep telling you that, hey, why don't you watch this? Hey, you watch this movie, I thought you would like this. In that way, it had made so many subscribers, it had made so many people to sit and watch shows. So this is where the Netflix problem they had tried to solve by using the recommendation system, and they are the first ones to implement this recommendation system and win the market. I want to take you back to those times where we used to watch movies mostly in the theaters. There was no Netflix. You either watch in the theater or watch in the TV, and then Netflix came, and the rest is history. You know how this has happened? By changing an entire generation, the way they used to watch movies, shows was changed by Netflix just by using this recommendation system. That powerful is your artificial intelligence. So your recommendation system is part of your data science, where you try to get the data, and then you try to understand how the user's likes and dislikes are, and you try to recommend them the product that they would want to do next. For example, um, market basket analysis is what I would say as an example. Let's say you bought a milk. What if when you're buying a milk, there'll be a person who would come and ask you, would you want biscuits along with that? Or for example, if you're buying some fruits, would you want some more other kinds of fruits? Something like that. So you go to a market and you're being suggested by the items, and one or the other you would try to buy, isn't it? That's how your recommendation systems and market basket analysis works, and that's how your revenue would be generated. I would talk more about market basket analysis little later after I talk to you about recommendation systems, but the major idea about market basket analysis is all about, if I place something in the cart, I should be ready to um, recommend you something similar so that you would venture to buy it, and that's how I can generate more revenue from this. So let's get into our recommendation systems part. What exactly is this recommendation systems? As you can see the diagram that I'm showing you, there are a variety of aspects that these users like, and these are the items. As you can see, this person likes these iPhones, um, you know, laptops and desktops, and this person likes umbrella, the generic utilities, and this person likes dresses. So different users have different choices, and connecting each of them to what they like is what is a recommender system does. So let's dive in and see more about Netflix, because Netflix was the company that showed whole of the world a way to use recommendation systems. I hope when you go to Netflix, you see something like this. When you switch on your TV, play something, either from Netflix or any other streaming website. So what this button does is recommendation systems. They aggressively do your they aggressively go and search your history, web browser history. They go and search the past history of movies that you watched, the genres that you watched, the interaction that you had done with the content. Let's say you watch a horror movie for 2 hours, and then you watch a comedy movie only for 15-20 minutes. So next, which would be my recommendation? You guys tell me. With this data that I have, what would you recommend if you were a recommendation system?
Horror.
Horror movie, right? So that's how recommendation systems work. This was a favorite meme that was there. Just wanted to show you to set the context. So this meme is all about, it says one of the person ordered a stool, and Amazon said, would you like to buy a fan, and wrote. So this is how the items are being recommended once you try to add something into your cart. But let's come to the reality. I hope this is what we all would see on Amazon when we are trying to buy certain product. When you're buying one item, let's say structure and interpretation of computer programs book is what you're trying to buy. It further asks, would you want to combine that book with the other book, something similar to that? And it also says customers who bought this item also bought these items. So this is what this piece of website is, what that is developed using recommendation system. Now there are two kinds of recommendations that you can do. One is item related recommendation system, the other one is user related recommendation system. Throughout this recommendation system concept, I would want to give examples in two methods so that you would understand better. One is Amazon.com is what I'm gonna use. The other one is Netflix, because most of you would connect to what I'm saying when I relate to these examples. So item based recommendation system is this part where when we are trying to buy a book, something related to computer program, it tries to relate pragmatic programmer book along with this book. But if you see this part of the website, it says customers who bought this item also bought these items, which means this is user based, isn't it? So I am a person who is buying, let's say, this book and this book, and you are the person who is buying this book. Then as a recommendation system, I can suggest this book. So that's how your user recommendation system works. It works on the way, collaboratively, the way other users are buying. Let's say if I have to give you a Netflix example, let's say I watch horror shows and then I also watch comedy shows, and then you are a person who watches horror shows and you also watch romantic movies. So I would be suggested with romantic movies and you would be suggested with comedy movies, for the sole reason that we both like horror movies. So that's how this works. the previous example of Netflix that I gave you is an item based. The recent example that I gave you is a user based. So your whole of your recommendation system is divided into two ways. One is item based and the other one is user based. And then we have something called collaborative, which is using both items and users that we're gonna learn. This is the example that I told you. So let's say this orange one is a horror movie. So there are two users who watch this and they also watch different genres. Then we can say categorize that these two users are similar and we can suggest these movies to each other. Am I clear? Am I going too fast or are you guys understanding what I'm trying to say?
Yes, sir.
Great.
Not
Thank
too fast.
Thank you. Please feel free to jump in and ask questions because I'll get terrified if you guys are so silent. So please feel free and ask questions. None of us here are definitely not experts because nobody can be an expert to this kind of data science that is continuously evolving. So please consider me as one amongst you and ask questions. I'll be happy to answer. So I know this kind of diagram might scare you, but bear with me as I explain. Let's say we are the users and we go ahead and watch movies and we try to rate each movie. So based on this movie rating, I can categorize on what kind of movies you would like during my data pre-processing. After pre-processing the data, I can relate the users who are liking similar content as I showed you in my previous figure. So I can compute the similarity between the users, and let's say this target user is me and these are the similar users like me. I would give a prediction that this user, which is me, would like these recommendations. This is how your whole of your Netflix recommendation system works. And this kind of concept is being utilized almost everywhere in the e-commerce industry. Wherever a product and you are trying to sell a product, if you're creating a platform that sells a product, essentially that is called an e-commerce, then you would be using your recommendation system using this concept. So I want you all to understand this particular slide very well. Let me just repeat it in case anyone had any doubts on it. Let's say we have all the user data and we have all the movies they have watched and the corresponding rating that we have. Using this data, we try to pre-process it. So pre-processing is nothing but not always the data that we have will be clean. We'll try to clean it in a way. For example, let's say this rating column, we have rating and also certain comments by the users. But we don't want to look at the comments. We just want to have that rating. Let's say this is in the form of I'll give a rating 5 and explain how good is the movie. I don't want this explanation, I only want the number. So what I would do in data pre-processing is that I would take up only the numbers in this particular row and I try to proceed and do the similarity computation. So that is how so similarity computation involves a lot of mathematics that is being used as a function in Python. So when you implement recommendation system in Python, it's gonna be very easy. You just call the corresponding libraries and you just try to compute the similarity in one line. But the kind of mathematics that is happening behind this is whole lot of a mathematical science that I would suggest you to learn, because by learning a lot of math that is being involved in artificial intelligence, you would be ready to define something new, like how Netflix did for similarity. You would try to calculate something new. As I said, the market analysis and also the market basket analysis is a huge science where you can always try to bring in new variables in it and you can try to build a new system. This pandemic had opened a lot of scope for us to learn that whatever we have might change suddenly and you will have to redo and rebuild everything from the scratch, isn't it? So that's why anyone who is trying to learn data science should also learn the maths behind that. And if you ask me how much math I learned, I'm still learning. It's very tough to crack math, what is behind the artificial intelligence, but trying to apply it in Python becomes very easy because all of them are compressed into a simple function or a library. So that's how we try to implement this in a company by just coding it in Python. And using that similarity computation, we try to define who are these similar users and try to predict the recommendations. This is how a Netflix pipeline works, recommendation system works. Any questions in this before I proceed? Anyone has any questions? Okay. I want to show you something that has come up very newly. So the amount of time that you would take to build a recommendation system is very high, but Amazon has come up with its own offering. It is offering a software kind of a thing in AWS where just by using that software you will try to get the recommendations within 15-20 minutes. It's just that you load the data, you create you try to personalize it based on your business, and you just get the recommendations out of it. How cool is this? This is very new. There's a whole lot of things that you do manually if you do, but this has made the life of a data scientist very easy. Now you don't have to code, you just have to make sure that everything is in place. So this is the kind of advancement that has come today. Like last year, I never came across such kind of thing. I think this was the new software that was inscribed in AWS. So this is the context, guys, for us to understand what is the importance of recommendation system, what exactly is this business intelligence, what exactly that we try to do as a data scientist. Though all this regarding data science and artificial intelligence, I only spoke a little, but there's a whole lot of it I wanted to talk, which I would talk at the end. But most wantedly, I want to talk about the recommendation systems. How do you categorize these recommendation systems? Is by model based, I mean the content based, which is item, or else the interaction between the user and the item. And then you have collaborative filtering method. So this is the method that is being implemented on your Netflix. It takes both the input from the user, also from the item, and it tries to collaborate in both the ways and tries to give us the recommendation. Hybrid methods, it is mix of both popular plus collaborative filtering. So it's like just because it's popular you wouldn't like it, isn't it? Just because it's being watched by many people you wouldn't like to watch it. So how would I suggest you something which is very popular that you would like is what a hybrid method would do. So trying to make sure that your home page is personalized is what is the target of a recommendation system. That's what your Amazon.com and homepage and my Amazon.com homepage will be quite different. This is because the way we interact with the items on the site are different, isn't it? You try to you might be interested to buy something else, which I might not be interested. So that is how your personalization works in an e-commerce website. Recommendation systems are the most successful systems that have been widespread used nowadays in most of the social media and also mostly in the e-commerce guys. It is because using this personalization, we try to encourage the customer to buy stuff from our platform just by showing them that the items that they would like will help us to will help us to gain the revenue from them. So you can find a large scale recommendation system in retail, video on demand, or music streaming. Nowadays, there are so many music streaming apps that are being in the market, that have come into the market. They try to recommend you the songs which you might like. For example, very basic recommendation would be something on, if I am continuously playing songs of a particular singer, any new song that comes up from that singer would be recommended to me on my homepage, such kind of a stuff. And I hope we all go to Google, and in the phone, if you go to Google, it gives us the news. So the kind of news that I would see and you would see would be very different, because based on your location, you would get news, local news, and you would also get news that you would be interacting more about. Such way you would personalize your news also. There are so many recommendation systems in terms of restaurants. I can give you an example on Zomato, wherein the way you order your food is being tracked, and based on that, they give you like biryani so much, so why don't you order it from this? I hope you are getting the notifications from Zomato. So, all that, how do you do is just by utilizing the data, that the way you are interacting with the data, and the way you are interacting with the items that the platform is going to offer, and also the way similar users are interacting. That's why that's how you create your revenue. That's how your Zomato is creating your revenue. That's how your Amazon is creating your revenue. So why this recommendation system is so important? It is because your recommendation system can help you gain the customers who wanted to buy it. It reduces the gap between those demands of the customers, and also the surplus amounts of uh, products that you have on your platform. You wanted to make money by selling your products, and there are customers who wanted to um, buy these products. So you need to bridge the gap using these recommendation systems. On a lighter note, just to give an example, so when I wanted to give a guest lecture in Vijayawada, so what should I do? I should be making sure that I would ask all my contacts that, hey, I was giving guest lectures in many colleges. Would you want would you know any of your contacts that wanted a guest lecture, kind of stuff. So without that kind of reaching out to customers, you wouldn't get. The other way is by recommendations. So how I ended up giving a lecture to you guys is by a recommendation of someone to ma'am today. So that is how your recommendation system works, and that is why your recommendation system is very important, because recommendation system essentially closes the gap between the customer and the platform that selling the products, and thus it generates a lots and lots of revenue and engagement. So, what are the kinds of recommendation systems that we can build? What could be our approach? One is popularity based approach. For example, if you open Netflix, it would say top 10 trending in India, top 10 shows trending in India, such kind of thing, just by popularity based. Next is content based. We discussed a lot about how a person would be suggested based on the content. As in, let me repeat, if I like to watch horror movies, I would be continuously recommended with horror movies. Collaborative filtering is what I had been talking, that you would be seeing a lot in today's websites. For example, uh, that I told you about horror movies and comedy movies. If I keep watching these two genres, I would be recommended with both the kinds of genres, but also those genres which similar users also likes it. The romantic movies that I just told you. So these three genres would be continuously recommended to me on my homepage using collaborative filtering. So these are the key approaches that we would do. How does this popularity based recommendation work is that we try to recommend items that are viewed and purchased by most people onto the users, and we rank them based on the purchase count or the view count. For example, popular news. So something that is breaking would come up into all of our news feeds, isn't it? It doesn't matter how which kind of news we watch. For example, let's say the war between Russia and Ukraine. Whether we all are interested in world news or not, whether we had interacted or not, this news would pop up in our Google News. That's the example. So what does this popularity based recommendation systems use? The same thing, the way we do the purchases, the way we text, as I told you, if we go to public platforms and say I want to buy something, that text can also be used to personalize your uh, homepage. And user and item features that we spoke a lot about. But the did you can you think about the problem in popularity based recommendation systems? It is that you can't find a personalization in it. Let's say there are top 10 shows on your Netflix page, and you don't like any one of them because you're not interested in those genres. So this is not a personalization to me, it bores me. So I wouldn't watch Netflix. Now I go to Amazon.com to see what I want to purchase. If I say your Amazon.com page says these are the top 10 products that are being sold throughout this year. It has mask, uh, it has sanitizer, it has all of this COVID kit stuff. Do you still buy this COVID related stuff now, guys? And what if your Amazon.com has that on your homepage? What would you do? I mean, would you not just forget what you're trying to buy and leave the home page? That's what it happens, right? So this is the problem with your popularity based recommendation system. It does not give any personalization. Another example is a song recommendation model. Let's say you were continuously given a popularity based songs and most of them you wouldn't understand. Let's say there's a Punjabi song that's being so popular in many different states, and you don't understand Punjabi, and you just try to listen to that, you wouldn't understand and you stop listening. But instead of that, just imagine what if I would recommend songs that you would like. Let's say you like melody songs. If I continuously recommend those kinds of songs, you would keep listening to those songs, isn't it? So that is the problem with your popularity based recommendation systems. And that's why we go ahead with the content based recommendation systems. So these recommendation systems works with the data that the user provides. So based on the data I provide, this recommendation system is built. So definitely there's a lot of personalization in it. And I don't know whether you observed or not. Most of the time, you get bored after a little time by listening to the same kind of songs or by watching the same kinds of shows, isn't it? Though you are the user, though you had already liked them, sometimes you get you would want something new in your life, isn't it? That's when you do something related to your collaborative filtering. So before going to collaborative filtering, I just want to touch a couple of points on content based recommendation systems. So these content based recommendation systems may not use a lot of user data, so they wouldn't know most of my likings. They would know only the way I interact with them, right? So that way the personalization will die down with time. So it doesn't make sense after certain time. It only requires item data, and we can start giving recommendations to the user. So in this kind of content based recommendation system, there's something called cold start problem. So when I just create a website with content based recommendation system, what should I show in the starting of the website? So you created a new account in your Amazon.com. So what you as an Amazon employee would show to that user, you can't show anything because he never interacted on your platform, right? So that way your content based recommendation system has a challenge that it can't show you anything in the starting unless you keep interacting with the data, sorry, with the item. And this the problem that I just spoke to you before changing the slide was about the dynamic. It wouldn't change because it keeps showing the same content that I liked previously. So my new likes wouldn't, the system wouldn't know my new likes, or it wouldn't suggest me something new. So that is where the challenges of content based recommendation systems lie. And now this collaborative filtering is something that's being used everywhere. Now, what is this collaborative filtering? It is also referred as a social filtering. So, this uses the information from the other users also, the similar users that you already have. So, for each user, this recommendation systems recommends items based on their data and also the data that they get from the similar users. And that way, your homepage would look more lively. Let me give an example. So a person wants to watch a movie and he would ask recommendations from friends. That's how we were doing before, isn't it? So the recommendations of some friends who have similar interests and are more trusted by us, we take recommendations from them, and this information we'll use it in the decision making that we would make to watch the movie, isn't it? So this is how intuitively we do, and this is the same thing that we apply in collaborative filtering. So this is all about the concept, but if we have to go into the technicality of this collaborative filtering, how does it work, is what you see on your screen. So this particular particular collaborative filtering can be of two types. One is memory based approach, where we find similar users based on cosine similarity. So cosine similarity is something that we use to calculate the similarity between the users. So we basically find similar users and we try to recommend based on this particular technique. And in this approach, the advantage is easy creation and explainability of results. And we can easily create results, but we wouldn't have to also have explain them to all the users about what kind of recommendations they would be getting, because we already calculated the similarity. What are the disadvantages that we have is the performances reduce when the because the data is sparse and we can't scale it. So we can't really say what would the user want after few months of the usage. So here is where we try to utilize model based approach. So in this model based approach, we try to use machine learning models that tries to give us the similarity in a more concrete manner. So previously it was just a casual cosine similarity, and now we try to use machine learning models to predict the user's taste. Now, when I say machine learning, we can go ahead and apply artificial intelligence, which is nothing but deep learning or usage of neural networks, wherein these neural networks, when supplied with lots and lots of data, can give you accurate results on how the users would want to watch or how the users would want to buy the products. Now, what exactly are the advantages is that we can remove lots and lots of dimensionalities that a user would have. For example, let's take an example for e-commerce alone. In a pandemic situation, so pandemic situation is one kind of factor that would affect you the way you buy stuff, isn't it? You wouldn't want to buy a huge TV when the pandemic kicked in, isn't it? Because Just imagine those situations back in 2020 when you don't know anything about this disease. You wouldn't want to go and change your TV that you already have, which is working fine, isn't it? Instead, you would go and try to buy masks, the kits, PPE kits, and all that stuff. So, these are the kinds of dimensions that come into play when you are trying to understand the market. In these situations you would need certain dimensions to be cut down. So how do you do that? How do you generalize it for everyone is by using different techniques that are there in data science. So these are called dimensionality reduction techniques. So for a particular user there will be multiple scenarios, but generalizing the scenario for him and trying to suggest something, recommend something is what your dimensionality reduction does. And what is the disadvantage is that there can be so many factors that we might be ignoring. What if in the previous scenario that I told, the customer is well placed in a scenario where he wouldn't get corona and his TV is in a very bad state that he would definitely want to change it. So we can't take a decision for them, isn't it? So by using dimensionality reduction, there is also a high chance that we are missing out certain customers. What I'm trying to make it a point is that even though you use collaborative filtering, even though you use whole of the latest tech, it might not be personalized, but to a certain extent, to 50% to 60% or 40%, there would be certain accuracy in your recommendation system that the customer would buy something on your platform. So doing all this would definitely yield certain revenue results to you at the end of the day. But I wouldn't say just by applying this you would get a lots of revenue. It's not like that, but definitely I would say it is directly proportional to your revenue. The amount of money that you would spend on this tech would definitely give back to you in a lots and lots of folds for sure. So as I said, there are a couple of ways collaborative filtering can be done. One is item based and also the user based. Item based does the computation of similarity between the items. In user based, you do similarity between the users. How does this user based collaborative filtering work? We already saw one example. So the example that I gave you, when there are two users and they watch different kinds of genres, but there's one common genre that they both watch, so you interchange the other genre to each of them and recommend them. That is your user based collaborative filtering. And your item based collaborative filtering is about the way I told you during market basket analysis, when there's a customer who is buying a certain kind of fruit, you try to go ahead and suggest some other kind of fruit which he might buy, right? So, for example, in a summer season, you would go and suggest mangoes, isn't it? So, that's how your item based collaborative filtering would work, both between the items and also between the user similarity. So based on, by taking the users into consideration, so there's a user who buys a lot of mangoes but at the same time would love to have certain watermelons. So there's another user who buys a lots of watermelons and nothing else. So what would you do? You can suggest this other user mango. This is how your item based collaborative filtering works. This is a small exercise for you, maybe. If you can take a screenshot and just play with this. As you can see, there's a user here. Let me explain about the puzzle that I just gave you. So there's a user here. He likes this picture. He wouldn't want to touch this book. He likes this video and he likes to play game. So would you recommend this picture to this user based on the likes he has, or else would you recommend this book to this particular user based on the liking he has? So using the data that was there, you will have to say whether you do a thumbs up here or a thumbs down based on the data that's there. So you need to connect these users and try to answer this question. So this is a small exercise for you to play around to understand the recommendation system. Going forward, if I have to tell you which is the best way of your collaborative filtering, it is item based collaborative filtering. Why it is more efficient is because your user can change his mind at any point of time. So depending on an user based collaborative filtering would be a bad idea, but if I do a item based collaborative filtering, it would still be a good idea, because I would be suggesting the items based on the similar users. That way my recommendation system will have certain accuracy in getting the revenue from the customers that we have. So, boiling it down to the strengths and the issues that we might have in collaborative filtering is that it is content agnostic. Based on the content it tries to suggest, it does not require items or users to be related with the content information. It can straight away tell you that it can at least do a item based collaborative filtering and give you the recommendation at the start. Uh, so recommendations are very close personalized, which means the way I would have the homepage would be different. The way the other user who is not similar to me will have a definitely different homepage. Issues, there's still a cold start problem, that when a new user creates a new account, you only have items to recommend. You wouldn't encourage that user to buy something. You can't woo that user already because he's a new entity in the system. There's a lot of sparsity, because unless and until we have a lot of data from this new user, you wouldn't be able to suggest it. And there's a lot of bias because of the similarity that we assumed. The whole of our assumption is that we assume that the users who are similar would definitely buy the product that each other was buying, which might not be the case essentially, isn't it? So you might not buy a case you might not buy a product just because most of the similar users are buying, isn't it? So this is called as popularity bias. Scalability, as in you can't uh, scalability is about the kind of info that you already have, as in you can't compare a user who had bought 100 different products in 100 different categories, and you can't relate it to a user who has bought only 10 items from your e-commerce website. So you can't do that scaling. So you can only compare this 10 the user who bought 10 products with some other user who had bought something around 7 or 8 at least, or 20, something like that. So there is the scalability problem. This is an issue because you can't generalize the person who had bought 100 products in different categories and then relate them with a person who is new to the system. So these are the issues that we have in collaborative filtering. I know this needs a lot of brainstorming, but this is how a data scientist works. Any kind of wrong thought process or any kind of bias that this person has would be reflected into the whole system. So that is the reason why your data scientist should be having thorough knowledge on where he is applying this kind of recommendation systems, and it would definitely need a lot of uh, testing to be done before taking this into the production, as in before going live with this particular system, because without testing you can't release a product without any popularity bias, without any scalability issues. So that is why we learn these issues conceptually so as to make sure that when we are trying to build a recommendation system, we make sure that we wouldn't do these mistakes while building these recommendation systems. So that's why a thought process is very much important for a data scientist, and you can build this kind of thought process only when you are uh, ready to go through certain case studies on the e-commerce recommendation systems that were already there, for example Amazon.com, Flipkart, anything as such. So when you are trying to start off, you should be learning from the market leaders or who are already there. So this slide, I just wanted to show you the model based collaborative filtering, because that is being used aggressively everywhere, and my favorite is this one where you try to do multi-layered neural networks, which is called deep learning, which is trending, and it can give you best accuracy. There are so many products that are using this deep learning to give you recommendations that I just showed you previously. Amazon personalization was what this one. Amazon Personalize is a product that is trying to give you recommendations automatically in 10 to 15 minutes. So that is being more you that might be using this model based collaborative filtering. So yes, I have come to the end of my presentation. I hope I gave you a fair idea about recommendation systems and how you can customize the experience, homepage experience or your shopping experience for the user on your homepage, so that he would be encouraged to buy and provide you more revenue. Yeah, so why I had kept this site is that you might want to connect with me on different platforms, and you can just find it in this link. So you can find the LinkedIn where you can connect with me. So feel free to connect with me. And yeah, thank you so much for listening to me. I am looking for questions. So if you have any questions, please feel free to come on the voice or on the chat and ask me questions. I'll be happy to repeat any part of the presentation in case you wanted to understand it better. And would also want you guys to give me a feedback in case if you could spend a moment. It would take just one moment if you could fill out this form for feedback, because using this survey I am drawing insights for the guest lecture I am giving, whether it was good or the areas I could improve. So that is why this form. Yes, I'm looking for questions. I'm just showing you the way the form looks. It has only 3 questions, so feel free to let me know what you liked and where I can improve. So that will help me. Yeah, anyone has any questions?
Hello guys, any questions? Let's share your experience on this topic. Anybody? '59 Kirti, Manogna.
Yes, ma'am.
Share your experience on this program. Can you share?
So thank you for your valuable time. I think this session is very helpful for us to know how recommendation system works in e-commerce websites. Thank you, sir.
Thank you.
Any questions? Thank you, Andeep.
Thank you, ma'am. Thank you for the opportunity.
Raman Lakshmi is here to present vote of thanks.
Yeah.
I thank our management, principal sir, for initiating this Industry Institute Interaction Program. I thank Mr. Anudip Sri Bhattana for taking time out of his busy schedule to interact with us. Thank you, Anudip, for an informative lecture on e-commerce and revenue generation using recommendation systems. We covered a lot of so many topics like what is big data, starting from big data, and what is business intelligence, why the market analysis is very important in today's real world scenario. And thank you for sharing your valuable insights with our students. Once again, thank you very much.
Thank you, ma'am.
Thank you.
Thank you. It's my pleasure, ma'am. Thank you.
Personally, I wish you great success in your future endeavors.
Thank you so much, ma'am. Thank you. Yeah, thank you, ma'am. Thanks, everyone. Have a great year ahead, and wishing you all the very best in your careers. Thank you. Bye.